Okay, so we're going to discuss about the OOPS concepts that are available in Java. And so let me open up Notepad. So basically, OOPS is a set of rules or a set of standards that all the programming languages who say that we are OOPS standard, we are following OOPS, they used to follow. So basically, what are the different specifications available in OOPS? OOPS stand for Object Oriented Programming Structures. Fine. So what actually this object is, and like how this programming language is entirely oriented on this object principle, that we'll look right now. So there are four basic concepts. Say for example, abstraction, polymorphism, abstraction, polymorphism, inheritance, and the fourth one is abstraction, polymorphism, inheritance, and encapsulation. So let me put them into order. The first part is encapsulation. It will go on the top. Then abstraction. Before that, we need to have inheritance. Then abstraction and polymorphism. Okay, these are basically four concepts. Based on those concepts, we basically define what an object-oriented language should be. Now we're going to discuss about Java, right? We are basically discussing about Java. So in Java, how these four things are implemented, that we'll discuss. Okay, first of all, we're going to discuss about encapsulation. So if you look at encapsulation, like definition, it says that things should be wrapped together, right? So if you say something, you are not going to deal with the detailed part of that. Okay, if you want to like move something, say for example, if you want to play a song, you are just going to call a method or a utility to play the song, or you can call like the class reference dot play song. But that play song is a method which is basically having lots of intrinsic or internal behavior which is happening inside, right? Lots of things are taken into consideration. It deals with the operating system, right? It creates certain parameters, certain variables, does certain logic, and at the end it is achieving that playing song or something. But what we deal with is we just talk about the functionality. We say that play a song. Similarly, if you have a class in Java, we used to have lots of classes. Whatever we write, it goes into a class only. So whenever we talk about a class, say for example, if I say it's a person, okay, person is a class. So the person is hiding certain behavior inside that. The person will have a name, okay. The person will have its age, its gender, etc. So these are the parameters which are very much basic to a person, and the person object is built. The person object is built using these parameters. So if these parameters are getting some value, then we can say that this is a complete person object. Okay. So a person object cannot be defined without having these variables. So it is very much important to hide their behavior, to hide their properties, and accidentally, it's even security point of view. If you talk about security, somebody should not be like modifying this information without letting the object know. So if you want to change some parameter within a person object, say for example the person's name, the person object should be aware of that. So we used to put certain restriction. So for example, we used to put the scopes. We used to have the scopes. Scopes are different type of scopes are available. One is default scope, one is private scope, one is protected scope, and at the end it's public scope. These are the four scopes which are available in Java. If you don't define any scope, it's by default a default scope. If you specifically say it's a private scope, then it's a private scope or protected or public. So these four keywords, they have different meanings. And using these four keywords, basically we hide, or we used to basically achieve some security features in our class or in our objects that we have. So basically it used to hide the information from the end user. Then there is
I had
inherit.
a question.
Okay, go on.
So, Is there any difference between default and public, or both are same?
Yes, there is a lot of difference between these two things. We'll cover each one of them. We'll try to write certain code to understand how encapsulation works. Okay? Then I'll talk about all these four parameters. Okay?
Okay.
Fine. Now, as you have seen how these scopes are working, right? If you give a scope default to a method or default to a class, or if you give private to a class or private to a method, then they behave differently. Okay? Like these things are restricted to be accessed from a certain area, not from everywhere, right? So if you want to, like, if you take that thing ahead, okay, if you have a class, you have written certain things, you have made the class private or public, and there are certain methods which you have made private because you want those methods to be accessed within the class only, and you don't want anybody else outside the class to access these methods. You have achieved encapsulation. Now what happens when you want your class to be reused later on? Okay, so what you want to have certain, like, there is a class A and it is having a method A or B. There are two methods available. Okay, and if you're going to create another class B, and you got to know that the method A is also needed over here, right? So what you need to do, you need to extend, or you need to modify, you need to make certain more, you need to give something more to the class A's behavior. So in that point of time, what we call, we are inheriting the concept, or we are inheriting the properties, inheriting the functionality from class A into class B. At that point of time, we say that class A is super, or class A is parent class. Class B is going to inherit the information from its parent. Thereby, class B is going to be called as child class. Okay. So those concepts are available in inheritance. So in Java, we basically achieve inheritance with the example of, like, with the help of classes extending in another class. Similarly, interface being extended in another interface, and interface is being implemented by a class. So all these concepts are basically related to inheritance. I'll give you one great example. Suppose there is a bank account. Okay, there is a class which is called as bank account. Okay, so the bank account is going to have certain features. Okay, say for example, the bank account will have withdraw money, deposit money. Okay, say for example, these are the two methods available in bank account. Okay, it will be better when I start writing the code. It will make more sense. So basically, just for now, let's understand that if there is a class which is having certain parameters, certain instance variables, and certain methods, if we are going to create another class, the second class can inherit these methods or these properties in its own class. So the second class don't need to write some extra code to achieve which has already been achieved by class A or the first class. So we used to take the help of inheritance to achieve that. Okay, we use the keywords extends, implements. These are the two keywords which we use for inheritance. Then there is called abstraction. Okay, basically abstraction is a concept. Okay, it just gives us a different view. Okay, it gives us a different view. It's more similar to encapsulation. Only in encapsulation we just give the scope and we hide the parameter, the behavior, and we limit it into a specific area. Within a class it can be accessed, or within a package it can be accessed, or within a project it can be accessed. That is going to be achieved with encapsulation. But when we talk about abstraction, abstraction is something, it gives us a different picture. It gives us a abstract level view. So we're going to talk about, say for example, if you want to calculate area, right? So any type of shape that is available in market, any type of shape that is available that can be drawn, they have a method, they have a functionality which is called as calculating the area. Now, if you are talking about a shape and you're saying that shape, give me your area, okay, shape dot calculate area, then you don't know how the area is being calculated on that shape. But if you are talking about a circle dot calculate area or a rectangle dot calculate area, you are very much specific about what area is being calculated. Okay, so if we achieve abstraction, then we will be talking with shape. So we don't need to know what is the internal implementation of shape. It can be a circle, it can be a rectangle. But Java will make it very easy for us. We just need to call shape dot calculate area, And the area specific to that shape, the logic for calculating the area specific to that shape is going to be executed. So we'll have a shape interface or a shape class. Then we'll have two different classes of the child classes using inheritance. They will be called as circle, or they are going to be called as rectangle, or anything triangle we can take. And when we call shape.calculate area, at that point of time, if the shape is actually a circle shape, we're going to get the circle's area. If that is the rectangle, we're going to get the rectangle area. So that is something at runtime. If the implementation at runtime changes, we call that polymorphism. But the method to which we are basically calling, that is calculate area, that's an abstraction. We're just talking about calculate area, and the calculate area is basically implemented by two parts. It can be a circle or a rectangle. So abstraction is a concept which helps us give a clear picture, or it just gives such a just the methods which we need to call, and the internal behavior is going to be implemented automatically by Java. The same thing can be done within polymorphism. In polymorphism, it says that when we refer, like polymorphism, it's basically two parts. Poly means multiple, morphism means form. So a single reference, like we talked about shape, a single reference can behave differently at different point of time. So when we call shape.calculate area, sometime it is going to give us circles area, and sometime it is going to give us the rectangle area. Without making any change in the code, we are getting two different behaviors. Or the shape reference is having different forms. So that's what we call polymorphism. This is a dynamic polymorphism which happens at runtime, but there is another thing which is called as the static polymorphism, which is happening with the case of overloading. If you look at method overloading or class constructor overloading, then that is a static or a compile time overloading. So that is also a polymorphism or a static polymorphism, but when we talk about interfaces and their object creation at runtime, their implementations are different. That is a dynamic polymorphism. Now I know there will be certain questions in your mind, but let's go one by one and let's see if your questions, doubts are getting cleared or not, or at the end we can solve all of the doubts. So let's first talk about encapsulation. I'll start a project in Eclipse. File, new, Java project. Encapsulation we are already familiar with, but I'm going to talk more about the scopes, how these things are going to affect. So now we have a class called encapsulation example, project called encapsulation example. Then I'm going to create a new class, Java class, and the class name is, let's keep the package name com.example.encapsulation. Okay, so for example, I'm going to have bank account dot business objects, bank account. This is a class. Okay, finally let's click finish, and we have the class ready. So there can be different parameters for a bank account. The first one can be int, let's make it private, int account number, private string account holder name. Private, let's give it double balance. Okay, these are the three parameters with which you are going to start. So these are the three parameters which are all private, and let's create certain methods. Say for example, getters and setters, or we can have a constructor as well. So let's first create a constructor. Creating the constructor is very simple. You can use control space, it will open up with the default constructor. And if we want to create the parameterized constructor, we need to right click, go to source, and generate a constructor using fields. All the fields are selected, click OK. That's done. Now the next thing that I'm going to do, this bank account it's a class or it's a business object. It is having three parameters. And say for example, I want to have one more method which is dealing with withdrawing some amount from the bank account. So that method is going to be public. It's going to return void and withdraw. I'm going to pass some value. How much amount do I need to? Amount to withdraw. Okay. Now this method's responsibility is to withdraw some amount from the balance. Okay. So what it is going to implement? Balance equals to balance minus amount to withdraw. Fine. And doesn't return any value. We can have another method, public void deposit. It will have a parameter called debit amount to deposit. Fine, it's going to update the balance. Balance equal to balance plus amount to deposit. When we have such a case, x equal to x plus y, then we can change it to x plus equals to y, like balance equals to balance plus amount. So it will be balance plus equals to amount to deposit. Both the things are same. So we can either have this one or this one. Okay. So if you expand this, it is going to be balance equal to balance plus amount to deposit. This is a shorthand in Java. So we can do the same thing with withdrawing. So we can make it balance minus equals to amount to withdraw. Both the things are same. Now we have the class. It's having three different private fields. Using the constructor, I'm going to set the values, and I'm having two methods which are public, deposit, and all. Now I can have the getter setters as well. So I can use right click, go to okay, or you can directly use a shortcut. Shortcut is Alt Shift and S, or we can go with right click, source, and go to getters and setters, generate getter setters. So I'm going to select all the status getters and click on OK. It's done. I have all the status getters. It's fine. So now I have the class ready. Now I'm ready to create some bank account objects. So what I'm going to do, I'm going to create another class. This class is going to call as encapsulation test. Encapsulation test. Fine, click on finish. It's done. Now the class is ready. So in that I'm going to have a main method. In main method I'm going to create certain bank accounts. Bank account 1 equal to new bank account. It is asking for account number. So for example 1, the name is name, you can give. The balance can be I've given a balance. I'm going to create another bank account. Okay, now I have two accounts. Okay. So what is happening with encapsulation is I cannot directly access the account number, or I cannot directly set the balance. Suppose I want to set the balance of account 1 dot balance is not possible, because this is a property, this balance is a property of account object. So if it is given access directly, people can change its value and that will never be known by the object. So what I'm going to do right now is I'm going to go to the setter method, set balance, and I'm going to write over here sysout setting the balance from, maybe earlier it was this dot balance plus to new balance. So it is going to set the balance. So at least we'll have a record like what was the balance and how what is the new balance that is getting updated. So this method will have control over that. This method will get to know that. Suppose I want to just give the I just want to print the time when it is getting updated, setting the balance from this to this at this time at, then I can give a time over here. So how to take the time in Java? We have a new calendar dot get instance dot toast. So this is going to print the current day, date, time, etc. So I'll have an information whenever the balance is updated. The balance is set. Suppose I want to, if somebody is trying to deposit some amount, okay, so I can have check over there setting or updating depositing amount and how much amount I'm going to deposit, amount to deposit, amount to earlier balance that I had, this dot balance, depositing this much amount to this much amount, and the final balance is plus this is the final balance, right? Balance equals to this one. So I can take it in a new line so that I get the updated balance after that. So let's remove this part, this balance at which time. So this is the time when it is deposited, and at the end I can say like the final balance it's better to write this dot balance. Good practice. So whenever somebody is depositing some amount, we'll get to know that, and before even withdrawing money from account, amount to withdraw, and we can have the. There may be a case when you have zero balance and you have a less amount of balance and you are trying to withdraw more. So that is a case account is going to be negative. Suppose we don't want to make our account negative, we want to implement something. Over here we can write if this dot balance is less than amount to withdraw. So if your balance is 100 rupees and you are trying to withdraw 200 rupees, so 100 is less than 200 rupees. So this is a problem. So at that point of time we can write sysout not allowed to withdraw as balance is low. Fine. Perfect. And at that point of time we can throw an error, throw new exception balance low. If the balance amount is more, then it is going to update the balance. At the end we can say sysout updated balance is plus balance this dot balance. Fine. So basically with the bank account, as the members are private, we can see all the members are private, they're never given access outside the class. All the private members are given access just within the scope, okay, just within the scope where they're defined. And if we're trying to access that private field from here, it is never possible. So what we're going to do, we're going to save the balance. We're going to save the balance to some value. So this can be possible. After that, account 2 dot withdraw. I can make a withdraw amount of 150 rupees. Let's look at the values. So first account is having some amount and it's going to be updated with a different balance, and the second account is being withdrawn. So if I run the code,
question here. If you try to access this,
which one? If I try to access which one? Okay, I can't hear you. Devashish bhai, be a little louder.
value,
Mm-hmm.
then no message. Now, what I'm trying to say is,
Mm-hmm.
here you say that we cannot access the private members
Directly.
through that constructor, right? I mean, through
Through
that
the
reference.
Through the reference, yes.
Okay. Can you show me the error message while calling? I mean,
Yes, if you want.
accessing that member. So, what will be the error message it display?
Okay, say for example, I'll have another account to dot name. Name is a field, right? Account name or something was there. Account holder's name. If you want to access it directly, you cannot access it. Equal to some value. Zoom it. Got it? It says that this account num is not visible because it is a private field. Okay. So as it is private, it is not visible outside the class. That's the reason. The field bank account holder's name is not visible. But if you make it public, it's going to be visible outside. Now see, the error is gone. Right?
Yes, got it.
Okay, so this is not possible with object-oriented principle. So what object-oriented principle says that whenever you are writing a class, you need to have all the fields within that class as private. Okay, if we say that we are strongly developing a project in Java which is following the object-oriented principles, then it is mandatory not to have any field as public. All the fields should be private by default. Okay, any access to that field, if you want to give any access to that field, you can have a separate method using getter setter or some specialized functions, and you can write to business logic. You can handle the problem if you're having any problem. See, this is a problem if the balance is low, right? So all these problems you can handle yourself. This is a new keyword through new exception, which we'll talk in a separate class how the exceptions work. So we'll basically discuss about that. This is basically a case where the programmer or the software doesn't want the user to make any changes which is unnecessary or which can cause some problem. So we throw an exceptional situation over here so that other code which is just ahead of it and not going to be executed. That is something we are going to learn. But that is again is handling a security case for us, right? It can make the balance negative. So it is going to handle that thing. But if what would have happened if I have made it public, somebody can directly access the balance and they can set the value as, say for example, account 2 dot balance equal to -1234. So I can make that possible, right? But this is wrong. So if we don't give this access, public access to anyone outside the class or anyone outside the class, then we need to make it private. So this is a strong object-oriented principle. All the private fields, all the classes private field, classes instance variables needs to be private. Now there are 3 more scopes available. We'll talk about them as well. See, the first field that we have discussed right now is the private one, and we have seen how the public even affects, right? If you make it public, that variable or that method is accessible from anywhere. Okay, whoever is having access to the class, whoever is having that class reference, who can create the class reference, they can access it. Now we are going to make it private. We have already made. We are going to make it default, and then we'll check with protected. Okay. So protected is also called as package scope. So before that, we're going to make default is going to be called as package scope. So we're going to check how default works. So I'm going to create another field, and that field is not going to have any private, any public, or anything. Directly, I'm going to call it. I'm going to give it gender. Say for example, character gender equals to, I can make it male. Okay, and this method you can see it is not private, right? So this whichever variable or whichever method is not having this scope, by default it is assumed that they are having the default scope, or they are having a scope which is accessible within the class, even outside the class, but not from everywhere. only from the same package. So the package is com.example.encapsulation.bo. So any other class who is present in this package, example encapsulation.bo, they can access this field directly. Okay, and if a class is present outside this package, anywhere outside these classes, they can never access it. It will be like a private field for them. So what we're going to do right now is we're going to look at the encapsulation test. You can see this is in the same package. This package and this package, they're the same package, right? So if that one is this gender is a default scope variable, so what I can do, I can directly account to dot gender. I can directly access that. I can make it better. Understood? Because gender2 is a default scope value. If I am going to write the same thing in a different class who is not in the same package, I'm going to create another class. But this time, if you look at the package name, see the package name needs to be encapsulation.bo. I'm going to put this class into a different package. Say for example, util test bank account encapsulation test 2. Okay, now I'm going to, this is a different package, com.example.encapsulation.util. But this class is present in the BO. Bank account is present in BO package, and bank account encapsulation test is present in util package. Now I'm having a main method, okay, which is having everything, and you can see the only error that we are seeing right now is with the gender. It says the field bank account.gender is not visible, right? So either we can make that public, or we're going to create a setter or setter for that gender. So it is going to give two fixes as well, change the visibility of gender to public. So I'm not going to do that because it's just for testing purpose. So if you make it public, if you click on this, it is going to be public and the problem is going to be solved. If you look at this, it has become public. We just need to save the class. If you click on save, and if you come over here, now the problem is gone. It should be gone. One sec. Public gender, now it is gone. Because it takes some time for Eclipse to compile the class and give the proper scope and proper visibility over here. Now you can see as it is public, as we have already seen, now it is resolved. But if the scope is default, see the scope is default, it is creating a problem with this. But the same code is written in a separate class, it is not having any problem because this class is in the same package. So this default scope is also called as package scope. Now we have understood three scopes: default, private and public, right? Next one is protected. So protected scope is not completely private, not completely public, okay? So how to understand that? When we are going to understand inheritance, we'll have two different classes, one class extending another class. Then we're going to look at how this protected is behaving over there, right? Protected is going to stop the inheritance after one level of extension, or after one inheritance, protected variables, they become private. They are no more accessible. We'll look into that. So this first part, from the first part, encapsulation, we have understood default. Default gives access to the package level. It is not accessible from outside the package. Private gives access to just within the class. Public gives access to the class, within the class, outside the class, within the same package, or even from a different package. It's not a problem. Protected is going to behave differently when we are going with inheritance. Okay, so let's do one thing. Let's go to inheritance. And before that, if you have any doubt with this, let's discuss about that. Seems clear? Okay, fine. Now what I'm going to do, I'm going to let's create a different project. New Java project. And this time the project's name is going to be inheritance example. In inheritance example, I'm going to create a new class. Package in com dot example dot inheritance dot business object. Name is going to be, let's create a class. The same bank account we're going to create right now, or let's create an vehicle. Okay, so we're going to discuss about inheritance with the example of vehicle class. So a vehicle, if we talk about a vehicle, it will have certain properties, right? So as we know, using Java's encapsulation method, all the properties are going to be private. So I'm going to make private string brand name of the vehicle. Can be Honda, right? It can be any other brand that we know. So it's going to be a string private floor price private twin model private color. We can have a color. So these are the fields which are color is a string. So these are the properties of a vehicle, irrespective of the type of vehicle. We don't know what type of vehicle is it. Is it a two-wheeler? Is it a four-wheeler? We have no idea about that. But even if it's a true two-wheeler, it will have a brand name, it will have a price, it will have a model name, it will have a color as well. So all the vehicles are going to have these four parameters. Now what I'm going to do, similarly, as I have created the constructors, I'm going to create the constructor using Eclipse code generation tool. I can go to source, generate constructors using fields, and all the fields selected. Okay, constructor is ready. I'm going to create the getters and setters. Go to source, generate getters and setters. Done. Select all. Okay. Now we have created a vehicle class, proper vehicle class. Now what I'm going to do, I'm going to create an object of a vehicle. So I'm going to create a new class. This is going to be in a different package. You can see earlier it used to be within inheritance.bo. Now we are creating a new class within runner. This class is called inheritance test. This is in a different package. So I'm going to have a main method. I'm going to create a vehicle object. Say for example, Yamaha FJ. It's a bike. New vehicle. I cannot directly call the vehicle default constructor because I just have a parameterized constructor, right? So first I need to import because it's in a different package. Once imported, I am going to call the parameterized.
Are I am unable to see this your screen.
Okay. I'm trying to.
I don't know. It's my connectivity issues or yours.
Let's see. I'm sharing the screen again. Okay. Let me know if you can see this. Speed is okay. And upload.
The speed is fine.
This is the download speed. Upload speed
Yes.
matters. Upload is very high, 45 Mbps. I think that's great. It's not create a problem, right?
It's okay.
It's okay. So otherwise you can go through the video later on. Okay, and you can
Yes,
let me know
yes.
if you're having any doubt in between. You can let me know. I'll try to repeat it again. Okay.
Yeah, yes, sir.
Fine. So the screen is visible now.
Correct. It
I
is
have created a vehicle class. The vehicle class is having four private parameters called brand name, price, model, and color. I'm going to create the object of vehicle. The vehicle object is created with new vehicle constructor, but this constructor is asking for some parameters. So I need to give the parameters. So let me give the parameters. Okay, 1 second. The vehicle is having a default constructor. See, this is a default constructor. That is the problem, but we need to provide some value over here, right? Which needs to be copied into the instance variable. Let's delete this and create the constructor again. Source constructor using fields. I need to select all the constructors. Okay, now the constructor is ready. I'll go back to this one and it should throw some error, right? Now it is asking for the brand name, price, model and color. The brand name is a string value. I'm going to have Yamaha. Price is, for example, 65,000. Model is,
it's 11 o'clock.
yes, and the color is, for example, black. Now we have created the Yamaha vehicle. Now I'm going to create another vehicle, say Honda Civic. New vehicle, the brand name is going to be Honda. And the price maybe 12 lakhs. 3.2 lakhs. It's fine. Civic 12. So what we have done now, we have created two vehicles with different data, and okay, but these two vehicles are different. You can look at these vehicles. This Yamaha FZ which I'm talking about, it's a bike, right? And this vehicle Honda Civic, it's a car. They have certain properties or they have certain functionalities which are very different from each other. But if I say it's a vehicle, I'm not sure what type of vehicle is it. If I just look at the reference, because this object which is created, it resides in the memory, and we just refer to that memory location. Unless we access the data from that memory location, we just can't understand what type of vehicle is it. So if you just talk about, say for example, it's a vehicle 1 and it's a vehicle 2. So these are the two reference names, right? The reference names are just for pointing to the object which is created. So as we are talking about vehicle, we are not sure if it's a bike or it's a car. So what I'm going to do now, I'm going to inherit the problem. I'm going to create a new class called bike. So the vehicle is already having 4 properties: brand, price, model and color. I'm going to create a new class called bike. See, I'm creating this class within the same package as vehicle, because this class is a business object. So this BU is a shorthand for business objects. So bike is another class which I'm going to create. The bike is going to have certain parameters like private, string, brand name, private, float, price, private, string, model, private, what is the last one, color, string, color. The bike is having one more property which is very unique in the bike. Let's say for example, we can call, give me one example which is there in the bike and not in the car. A property. Okay, we can have a functionality later on. So see, these are the 4 parameters which are present already in the vehicle, and we're creating a bike, we're still writing them again. So in such cases, we don't need to write them. We can rather extend the behavior, the properties from the previous class, and we can remove these things. We can extend the behavior. The bike is going to extend the behavior of vehicle. That's done. Okay, now the bike is going to be created, okay, and it is going to have direct access to the methods and the properties or the instance variables of the vehicle. So the bike is having a method called as getPrice, The bike is having another method called as get brand, set model, get model, set color, and everything. So we don't need to write those things again. But while creating the bike, if somebody is trying to create a bike, it needs to call to its constructor. So we're going to write a bike constructor. The bike constructor needs to be parameterized because all the parameters are important. So we're going to create the constructor using the fields. So one second, right click, go to source, generate constructor from. Now there is a difference over here. You can see generate constructor using fields. As the bike class, it doesn't have any fields of its own. As they are being inherited from the superclass, we should go to the second option, generate constructors from the superclass. So you can see this vehicle class is having these 4 parameters. We can click on OK. And when somebody is creating a bike, he is going to pass all these values: brand, float, string, model, and color. And remember one thing, whenever a bike is created, it is indirectly creating a vehicle as well. So it's necessary to call the super constructor. So when we say super and pass these 4 values, it is basically calling the super constructor. The bike is a class, vehicle is the super class. So if I'm creating a bikes object, it should create a vehicle object indirectly. So that this is mandatory. We need to call the super brand name price. So this super is basically referring to the vehicle's constructor. So if I click on super control and click on that, it's going to take me to the vehicle constructor. So if I'm going to create a new bike, it's creating a new vehicle as well. So now I have a constructor, it's called a bike. And the bike, I created this bike just to mention some of the very specific functionality of the bike. Okay, so for example, we can have a CC. I'm going to create another method, public int number of pillions. And this thing is going to be different for bike and for car. It's going to return that only one person can sit behind. So this is a function which may not be present in class. Okay, and private. Okay. Now I'm going to create the same class. Now the bike constructor is ready with one more method. This method is available just to bike, not to vehicle. All the vehicles may not be having a pillion seat, but the bike is having it. So for example, this is a new method. The bike is going to write only the new method without writing the old things. It is going to extend the vehicle behavior. So the properties which are defined within vehicle object, vehicle class, they are automatically extended in the bike. They are automatically available in the bike. So if I want to do something like, say for example, I'm having any method public void display bike details. This is a method. If somebody is calling this method, it should print what type of bike and some sort of information about the bike. So sysout, if I say sysout brand name, brand this is the brand name which I already have over here. And the bike is extending. Okay, super dot brand name. Not able to. Okay. Vehicle is having a brand name which is private field, but I can call its setter and getters. See, I have not defined the brand name method within the class. Okay, I have not defined the brand name method within the class. As this brand name method is public within the vehicle class, if you go to brand name, get brand name within the super class, it is public. So all the public fields, they are automatically available in the child class. So if you have a parent class vehicle, there are certain 4 parameters which are private. They are never inherited. So they are not directly available within the bike class. But as the vehicle is having some of the parameters which are some of the methods which are public, we can access those public methods from here. See, I've never written any method set get brand name or anything, but I can still get an access to that. I'm going to create a bike object. So when I'm creating a vehicle, Yamaha, I can call it bike. I have to import the bike, Yamaha bike, new bike, and I can pass on these 4 values. And with this second vehicle object, say, for example, it's a car. If I say Yamaha bike, for example, let's call it a bike. Car dot, I can call bike dot display bike details, but I can never call car dot display bike details, display car details. It's not available because this method is available only for the bike class, not for the vehicle. But all the methods from the vehicle, they're available in the bike. Bike dot get brand name, that is available. Bike dot get price, that is available. So these are the methods which are inherited from the parent class, the vehicle, into the bike, the child class. But the child class is having a specific method which is just available for the child class. This is how basically the inheritance used to work. If we make the parent class property as private, it is never going to be inherited in its child class. If the parent class property is public, it will always be available to its all the child classes. We can have different types of inheritance, like multiple levels of inheritance. Now just have vehicle, and from that I have created a bike, and from the bike I can create again another sub-child class. That can go on. That's what we call a multi-level inheritance. We'll discuss more about different types of inheritance. We have just discussed one example. What is left till now is this protected parameter. We'll see how this protected is going to affect. If you make it default, it is available within the same class. We have already seen that. Okay. So tomorrow what we are going to see, we are going to use inheritance, and we are going to change the scope, and we are going to see how that scope is affecting from the parent class to the child class.